Alright, in this video we are going to talk about radical equations. You know, we radical equations. See, example, say 3 to the power x plus 1 is equal to x plus 2 to the 27 x minus 1. We got to find what is the value of x. See, on this equation, what we do, we say, okay, 3x plus 2, and this one, 27 is 3 to the power of 3. Because 3 times, we multiply 3 by 3 times, it's going to be 3 times 3 is going to be 9, 9 times 3 is going to be 27. So, we can say 3 to the power of 3 to the power of x minus 1. See, this one, if we can write it, see, if 3 is to the power of 2 to the power of 5, what's going to be? We multiply this exponent by this exponent. See, 3 to the power of 2 raised to the power of 5. So 2 times 5 is going to be 10. So this is going to be 10. See, the same thing for here. 3 is going to be multiplied. 3 is going to be multiplied by x minus 1. Multiply. So what is going to be the 3 to the power of x plus 2 is equal to 3 to the power of 3x minus 3. So here, when this is equal, when the base are equal, so the exponents must be equal to, means x plus 2 is equal to 3x minus 3. Now this equation, is it to solve? 3x minus x is equal to 2 plus 3, 2x is equal to 5, x is equal to 5 over 2. So x is equal to 5 over 2. And this equation, if we put 5 over 2, it's going to be the same as this one. Okay? So, we can check, we put x is equal to 5 over 2, and find that these two are equal. Okay, let's solve another example. 4 to the power of x 2x minus 1 is equal to 16 to the power x plus 3, for example. So how do we solve this? Did the base should be, we're going to make the base equal. See, this is 4 to the power of 2x minus 1. And what is 16? 16 means 4 to the power of 2, then to the power of 3. So what happens? 2 to x minus 1 is equal to 4 2x plus 6. The 2 is going to be multiplied by this exponent. So it's going to be 2x minus 1 is equal to x plus 6. So this is going to be, x is going to be 0, because 2 is going to be, come here, it's going to be 2x minus plus 2x is equal to okay, let's make something that we don't have 2x. Suppose that we put 2x here. What's going to be? It's going to be 4 to the power of 2. 2x minus 1 is equal to 4, 2 times this, 2 times 2x plus 3. So 4x plus 6. So 4x plus 6 is equal to 2x minus 1. It's going to be 2x, and this is going to go, it's going to be minus 6 minus 7. X is equal to minus 7 over 2. Okay? So this is the value. You can put it in here to see that you make it like this. If you put x 7 over 2, and here is 7 minus 7 over 2, this should be equal. Okay? And this is the second example. Sometimes you see that by use of logarithm we can find some of the things is hard to. For example, 14 to the power of x minus 1 is equal to, I don't know, 18 x plus 4. See how we cannot find a common base. Here we could find a common base to say 4 to the power of, this is going to be 4 to the power of 2x plus 6. But we can't do that here. We can use take log of both sides. Log of 14 to the power of x minus 1, log of 18 to the power of x plus 4. We get log of both sides. Okay? And what's going to happen, we can bring this one here, x minus 1, just behind this, we can bring it here and say log x minus 1 log 14 is equal to x plus 4 times log of 18. So what's going to happen here, we multiply this, you distribute it. X is going to be x log of 14. See, this is log. The base is 10. If there was something else, we put, if we had log of 2, then base 2 we put here to say 2. This is when we don't write it, is 10. So this is going to be x times log of 14 minus log 14 is equal to x log 18 for log of 18. See, they have x, we bring one side here. Okay? If we bring it here, x log 14 minus x log 18, because we bring this one this side, and this one will go the other side, and so the negative is going to change to positive. So log of 14 plus 4 log 18. Okay? So if we factor x, is going to be log 14 minus log 18. It's going to be log 14 plus 4 log 18. Okay? So x is going to be log 14 plus 4 log 18 divided by log 14 minus log 18. Okay, we can put all these in this calculator to find this. You know, we write parentheses here, log is log 14 plus 4 log 18 divided by log 14 minus log 14 minus log 18. Is okay, I made a mistake here. See, it's gonna be, see, you bring this one here. You see that what we did here, log 14 plus 4 log 18 divided by log of 14 minus it's like this. So it's going to be 44.85. So we find the value of this one. Minus 44.80. We rounded to 2 decimal places. So that's the answer. So this this way we can find if the base are not the same. We cannot make these the same. We use this one, log, using log. So it's sometimes you have natural, the natural log. This one doesn't we use like natural log. First of all, you know, natural log is just the same as log. You know, we say log of 2 base 2 x. What is going to whatever is going to be 8. What is going to be 2 to the power of 3 is going to be 8. If we have the difference between these two is natural log, the base is e. The base is e. So if we have something like this, see, natural log of e to the base of e is equal to be 1. Y is equal to be 1. Because if we raise this one, the base, to the power of this one, 1 is equal to be e. So natural log of e is equal to let's see, natural log of e. For example, let's solve the see, that was exponential equation. That was exponential equation that we talked about it. So if you have something like this, natural log of e to the power of x is equal to natural log of 5. You know that base of both these are e. But when we use natural log, we don't write this. We say ln. It means that natural log, the base is e. So how do we solve this? We say x, it's going to come behind it. X ln e is equal to ln 5. X is going to be ln 5 divided ln e. So you just put it in the calculator, you can find the value for x. What is ln? You know that this is ln e to the, it's going to be 1. This is ln e is going to be 1 because base is 1. And ln 5, we have it here. We have it here, ln 5, 1.61. 1.61 is going to be, we rounded to 2 decimal places, it's going to be 1.61. So whenever you see a log, natural log, then you use this. Let's find solve another one. 2 e to the power of 2 minus x is equal to let's see, is equal to 4. Okay, so we find, we get rid of this coefficient of this one is going to be e to the power minus x is equal to 2. This is going to be 2. Okay, because we divide both sides by 2, we get rid of the coefficient. Now, because we have e, we use natural natural log. So we say we get natural log on both sides. E to minus to the power of minus x2 is going to L natural log of 2. Both sides we get natural log. Because we have e. If we didn't have e side, like other words, we get just log. We get the log of that, log to the base of 10. So what we, how do we solve this one? To find value for for x, we want to find value for x. So we can write it like this: 2 minus x times ln e is equal to ln 2. So distributive, we multiply this by this is going to be 2 ln e minus x ln e is equal to ln 2, natural log of 2. So this is 2 is going to be 2 times 1, because ln e actually is base is e, so e to the power of 1 is going to be e, so this one is going to be 1. And x L is equal natural log of 2, natural log of e. So this one also is going to be 1. So 2 minus 1x is equal ln 2. X is, if you go x that way, is going to be positive, or you multiply both, all of them by minus 1. You can go, this one is going to go this side, is going to be positive, and this one is going to go this side, it gets a negative 2ln of 2. And we see that the result is going to be 2 minus natural log of 2. 1.306 and something. So if we round it to 2 decimal places, it's going to be 1.31. So we solve this kind of equations that it's so let's solve some other three to the power of 2x plus 4 is equal to 81. It is equal to 81. We can make both side the base 3, because 81, if divided by 3 is going to be 27, divided by 3 is going to be 9, divided by 3 is going to be 3. 3 is going to 81 is equal to 3 to the power of 4. So we say 3 to 2x plus 4 is equal to 3 to the power of 4. So the bases are the same. Now we add the exponent 2 x plus 4 is equal to 4. So if the bases are the same, the exponent should be this, must be the same, because these two are equal to it, are equal. So 2x is equal to 4 minus 4 is equal to x is 0. See, if you put x, value of x in here, 3, 2 times 0 plus 4 is equal to 3 to the power of 4. And this is going to be 3 to the power of 4 is equal to 3 to the 4. So this way we can check our answer. So this see, you got to look at the thing is 10 to the power of x is equal to 5. What we do, how do we find x? We say use log. Say log of both sides, 10 to the power of x is equal to 5. We say x log of, because it's the numbers. If it was e to the power of, we use natural log. It's easier that way. To the power of x is going to come behind it, is going to be log 5, and log 5, x is going to be log 5 divided by log 10. If you put this one in the calculator, you can see that log, log, let's clear the whole thing, is log 5 divided by log 10. What's going to be the answer? It's going to be 0.699 6989 7, and then so actually what happens, you see log of 5, this is going to be 1. See, actually it said that log of 5 was 6 point, suppose that 0.7, okay? It's 0.7. We just rounded to 1 decimal places. And this one is actually 10. The base is 10. What does that mean? Log 10 to the power of what is going to be 10? To the power of 1. So this is going to be equal to 1. So 1 is going to be 0.7. So this way, that's